Okay, now we're going to look specifically at just chemical reactions. Chemical reactions are where you take a sample of matter and it's completely transformed into different materials than what you started off with. When you look at chemical reactions, there are 5 descriptive words here that always indicate a chemical change, and that would be burn or rust, decompose, corrode, or explode. So anytime you see those words, it is always indicative of a chemical change. Chemical changes allow us to break down compounds because compounds can be separated by physical changes. Mixtures, homogeneous, heterogeneous mixtures, we can still separate those by physical methods, and we went over some of those in the previous section. In a chemical reaction, you have reactants and you have products. Reactants are what you start off with, and products are what you end up with. So I'll give you 2 examples here. The first one, there's actually 2 reactants, and that is carbon and oxygen. Those are your 2 reactants in this particular equation. I only have 1 product, and that is carbon dioxide, CO2. So I started off with 2 things, I ended up with 1 product. In the second example, this is actually a decomposition reaction. I'm starting off with 1 reactant, and that would be water. I'm ending up with 2 products, hydrogen and oxygen. And I know this is not balanced. We'll get to balancing equations a little bit later. But so you start with reactants on the left side of the arrow. The arrow just means yields or gives, and then you end up with your products on the right side of the arrow. There are 4 ways to tell if a chemical reaction has taken place. Number 1, a transfer of energy. If you mix 2 things together and the result feels hot or it feels cold, that's a transfer of energy, a transfer of heat. This can be exothermic or endothermic. Exothermic means hot. Endothermic means it feels cool to the touch. Number 2, if you mix 2 things together and they change color, that's always indicative of a chemical change. Number 3, if you mix 2 things together and they produce a gas, that would be indicative of a chemical change. Now watch out with the gas, because this has to be mixing things together to form a gas, because obviously if you heat something, it will bubble, but if you heat something, that in and of itself is not a chemical change. And then the 4th thing is the formation of a precipitate. If you mix 2 things together and you form a solid or a precipitate, that is indicative of a chemical change as well. So those are 4 things you want to look out for chemical reactions. Conservation of mass. In any physical change or chemical change, mass is conserved, and this is a scientific law that we use quite a bit in chemistry. Let me give you a couple examples here with these equations. In the first example, the decomposition of water, assuming I have 10 grams of water, and I know that I end up with 4 grams of hydrogen, I should be able to tell how many grams of oxygen are produced based on the law of conservation of mass. Because if I start off with 10 grams in the reactant side, I have to end up with 10 grams on the product side. And so just by simple subtraction, that leaves me with 6 grams of oxygen. So the law of conservation of mass allows us to determine the mass of a product or a reactant if we know all the other products or reactants. Look at this second example. Let's say I have 5 grams of CH4 and I react it with 11 grams of oxygen. And let's say I know I can measure water pretty easily. Let's say I have a mass of 13 grams of water and I want to figure out how much CO2 I produced. Well, again, law of conservation of mass says that if I start off with, in this case, I'm starting off with 5 plus 11, I'm starting off with 16 grams. I have to end up with 16 grams. And so that means my mass of CO2 produced, even if it escaped into the atmosphere, would have been 3 grams.